Hello everyone, welcome to the Conf42 Machine Learning Conference. I am Avaneendra Kanaparti, and today I will present a topic that answers a very pertinent question within the credit card industry and how we can leverage one of the most trending technologies to answer that effectively. And the topic is maximizing credit card profitability with machine learning driven customer lifetime value. Before we jump in, by way of introduction, I am the Director for Data Analytics at American Express, primarily focusing on small business and commercial credit card customers. In my role, I leverage advanced analytics and machine learning to design strategies that drive incremental spend and lend behaviors among customers while balancing the customer value and experience that we offer through the various products and managing the business risk prudently. In my career spanning over 15 years, I have been with major financial institutions like Capital One and Discover across various business units, driving product strategies, risk and response modeling to predict customer behaviors, and growing the business profitability while balancing customer experience. Today, I wish to share the knowledge and insights that I have gained over the years through my hands on experience with you. Now, let's take a quick look at what's to come. First, we'll start with a high level overview of the credit card dynamics, along with a review of the various challenges that are plaguing the companies in the current environment. We'll also introduce the concept of customer lifetime value here. Next, we can explore the role of machine learning and how we can leverage it to solve some of the challenges that the companies are facing today. Following this, we can review the optimal processes to convert some of these machine learning concepts into optimal business solutions. Next, we can review a few real-world applications to see what kind of a business impact can these machine learning solutions drive for the companies. And then we can take it home with a few key takeaways. Now let's jump in. We all know that credit card is a very powerful tool and very critical in our day-to-day lives. We do not think twice before making a purchase or a transaction with our credit cards. But what actually happens behind the scenes and what happens from a company's perspective? From a company's perspective, the overall customer lifecycle can be broadly divided into two distinctive phases. The first one is acquisition, which ends at the point of approval or decline of a particular customer. And the second phase is the customer management, which starts with the point of approval of a particular customer and goes all the way as long as the customer stays with that company. In the first phase of acquisition, we have a lot of activities, starting with the marketing activity, which targets a whole lot of customers with different marketing materials, advertising the credit card product, followed by the generous sign-on bonuses that the companies give out to attract customers when they get approved for a card. And then there is a whole lot of risk strategies that evaluate whether a customer is a good customer to be approved by the company or a risky one. And then there are some operational processes which happen on the back end as a customer gets approved or declined. As you can see in all these steps, they are very cost intensive and they require an upfront investment from the company to acquire a particular customer. This is typically called the acquisition cost. Then when does a company make back money? That is in the second phase of customer management. Once a customer starts using their card in making purchase transactions or revolving by paying the interest charged to the company on part of their transaction volume, that is when the company starts making back money. In the second phase, the company earns money but also incurs some losses in terms of some negative behavior from the customers who do not pay back the money that they owe to the company and they charge off. So there is a potential for both making money and losing money in the second phase, but this is where the customer lifetime value comes into effect. The upfront investment or the cost that they make during the acquisition phase and the net money that they either make or lose in the second phase is what makes up the total customer value over the lifetime of the customer being a member with the company. And next, let's see why this customer lifetime value matters. As you can see, the first use case is in the acquisition economics. This is the place where a company has to decide whether they need to approve a customer or decline them. The cost of approving a wrong customer is that they probably would result in like heavier losses, ultimately turning out to be a net loss for the company from a business perspective. At the same time, the cost of losing out a good customer is also pretty heavy, that they would leave money on the table for competition and they would not be able to maximize the value that they generate for the business and also that they generate for the customer. So as you can see, there is a very fine balance that happens between approving a customer and declining them. And all this is pursuant to what value do we attribute from a customer lifetime value perspective to a particular segment of customers or a particular customer, and what decision we make at that point. The second use case is in the portfolio strategy. Again, once a customer is approved by a company, it doesn't mean that like it's hunky and dory for everyone. As you can see from the current environment, there are a lot of changes that happen on a day-to-day basis, be it in the macro environment, or be it in the competitor actions, or be it even in the customer's profile on how they use their credit lines, not just with this particular company, but with all the other companies or like other forms of loans that they take. As things continue to change on a very dynamic basis, the company also has to make decisions on a dynamic basis to make sure that they are not overly exposed in the case of eventful turns, or they are not leaving money on the table by not maximizing the customer's usage. So again, here, as you can see, the customer lifetime value comes into play to make sure that the company is making the right decision at the right time to ensure that like they are maximizing the value for all the players. The third point is in the P&L forecasting, where we quantify the expected revenues that we can generate from a customer versus the potential losses that can come from any negative behavior from the customer perspective, and combining those two to make an informed decision at various points of the customer life cycle, and making sure that the decision is in the right sense for both the customer and also for the company. Now let's see like where machine learning comes into play. Historically, customer lifetime value or even the individual values for each decision were not driven by machine learning or by multivariate analysis. Things were mostly two-dimensional, and the effect of one variable was typically analyzed in isolation, and that led to very skewed decisions, very dependent on a few variables, while the majority of the other variables which could potentially impact the decision were neglected. Now, this is where the machine learning becomes a game changer in the decision making process. Typically, the model can analyze multiple variables at the same time to come up with a multivariate impact and predict the outcome based on the changes on a simultaneous change in these different variables at the same time. So that's where instead of analyzing like one particular variable in isolation and then another variable in isolation, the model helps combine the impact of those two changes at the same time and predicting what could be the potential outcome on the customer's behavior. And these predictive models are very good at taking in hundreds or thousands of variables at the same time and deciding on which are the topmost variables and which are the most impactful in terms of predicting the customer behavior, and then a specific model to utilize those variables. So what are the main components within the customer lifetime value modeling can we use machine learning? So the first one is the future spend patterns. As we were discussing, once a customer is approved, the level to which they use the card is one of the key components in deciding on like when the company makes back money and breaks even on that particular customer and the usage. So as you can see, how much would a customer potentially spend, and getting a good prediction on that will determine how valuable the customer is at the point of approval. For a customer who spends like heavy amounts, that is where like the company would make back a significant amount of the overall purchase volume in terms of the interchange revenue, and that will help the overall economics of the credit card. The second outcome is the revolving behavior. Once you make a purchase transaction, the customer can elect to pay back it in full, which is typically called a transacting behavior, or choose to revolve and pay an interest charge for the flexibility to pay back the purchased amount in installments. So this is typically called a revolving behavior or a revolver, and this is where the company earns a higher income based on the interest rate that they charge the customer. So accurately predicting who or like what kind of customers are more likely to revolve and like how much of an amount that they would revolve would help in accurate planning of like how much exposure should they maintain, how much reserves in capital should they maintain, and also what are the potential revenue streams that they can expect from these customers. The third one is in terms of the payment reliability. Not everyone would have the same efficiency to make back a payment and or the willingness to make a payment. So this is where like using machine learning to predict like the willingness of a customer to make a payment, their ability to make a payment becomes critical in understanding what kind of a customer behavior can they expect. If a customer doesn't have the willingness or the ability to pay, they are more likely to be a risky customer and display negative delinquent behavior, which turns out to be a loss for the company. Versus a customer who has got the means to pay back whatever they are spending or chooses to spend less than like what they can pay back are typically good behaviors that would encourage in the company also meting out good treatments to the customer. The fourth and the other cost component that we can predict using this machine learning concepts is the default probability. This is the probability of a customer actually going bad in the near future or in a slightly medium term of say 2 to 3 years. So this is where this is the part that helps the company to plan for any potential losses that can come from these negative actions that they give out to the customers. In the spirit of not being too conservative, there have to be some decisions made by the company where they give out like preferential treatment or like they approve customers knowing like what is the potential risk. So ultimately it boils down to the risk reward for each customer segment. So even though there would not be any customer segments where there is like absolutely zero risk. So there is an acceptable level of risk that the customer needs to decide based on its internal tolerance levels, its appetite for taking on risk, and like the required ratio of return that they can generate on the capital employed, and then make an informed choice on the relevant customer segments that they can venture into versus like what customer segments are absolutely out of reach based on the absolute risk that they pose. Now that we have looked at like, what outputs can come from the machine learning models, let's look at what actually goes into determining these components or like the outcomes that we just discussed. Over here, we see some of the primary categories that we typically use. The first one being on the spending metrics, which translate into the spending volume, how frequently they are spending. Are they using it like once a month or are they using it like pretty much like twice or thrice a day? What are the categories that the customers are spending the money in? Because there could be some categories which are like the daily things like spending at grocery stores, spending on gas, things like that, versus spending at a casino, which is typically a riskier transaction. The next is the payment behavior. How many times is a customer paying back? Are they paying back in full or are they making partial payments and multiple payments a month? And this could potentially imply how the customer's cash flow is and what kind of a risk do they pose. If the customers are making full payments like early on, then that is typically a good behavior versus if someone's making almost towards the end of the payment due date, and if they are making multiple payments in partial amounts through different sources, that's probably an impending cash flow issue that could potentially arise from the customer. Balance utilization is the concept where it is more prominent for the revolving customers. What kind of balance do the customers carry? How much of a credit line are they using? Are they using up all the credit line, which is typically a risky behavior, versus if they are maintaining their utilization in a good range, which is typically below 30%. Some of the external signals that we can also feed in are typically the income proxies, which are modeled income, and that also feeds back into understanding like what is the ability for the customer to pay back some of their balances, and some of the credit bureau attributes which talk about not just the credit lines with the current company but also with the other external competitors, and also the other types of loans that the customers can potentially have. Now that we have seen like some of these categories, we understand that like we have a lot of data that we can use to model these inputs, but that's not just enough. So once we identify these different categories or like the different variables that we want to feed into the model, which typically form the raw transactions, then we need to aggregate all these and enrich the data to make sure that it is in a easy to digest form for the model. Having a lot of missing values or having a lot of extreme values for a particular variable could skew the model, and that is what we need to avoid to ensure that we get a good output from the model. It is just like the adage goes, garbage in, garbage out. If you feed in like garbage random data, we do not expect to get a good output from the model. Once we feed in this cleaned out data to the model, we employ different techniques, which we review on the next slide. We can identify different behavioral patterns from these models and assign a cause effect relationship, and use this linkage to identify like what patterns within these transactions or the patterns by the customer would typically lead to the different outcomes that we discussed, be in terms of the probability of a default, or their willingness to pay, or like their probability of carrying a balance and how much balance would they carry. So all these different parameters can be predicted once a model assigns this cause effect linkage and identifies these patterns to predict the outcome behavior. Now, as we are discussing, there is this intermediate component of what is a machine learning approach that we can use to help the model assign these different linkages. And here we have three different approaches which are primarily used in most of the use cases. And the first one is the gradient boosting model. The XG boost or the light GBM are typically the widely adopted methodologies within the financial industry, and they help predict pretty much like all the outcomes that we were discussing. A couple of other models or the approaches are the deep learning methodology, which typically uses neural networks and recurrent networks and transformations to predict sequence behaviors and can be used for dynamic prediction. The third most used approach is the survival models, which uses different parameters to predict the time to event and is predominantly used for metrics like attrition and retention models. Now that we have reviewed the different approaches that we can employ to generate predictive outcomes and the way we can actually use the different inputs and the different variables that can be fed into it, how do we ensure that like the model that is being finalized or that is being used or would potentially be used in the business use cases be up to the market standards or be satisfactory and not have any bias in it? So the first thing that we need to ensure is to make sure that we use a temporal validation methodology, which is to train the model on a different time period and validate the model using a different time period. So if we have, say, 3 years worth of historical data that we can train the model on, instead of using all the 3 years and then validating the model again within a part of those 3 years will likely lead to overfitting bias. Instead of that, we need to use probably 2 years for training the model, and then like we validate the model on the remaining 1 year to ensure that like the model continues to perform equally well in both the time periods and it is not overfitting to fit only the training period. And the next component is the segment analysis. What kind of or what's the composition of the input data is very critical in deciding on if the model output can be used across different segments or not. For example, let's take like the transactor and revolver behaviors, right? So if we develop a model completely depending on the transactor population itself and feed that as the input, the model designs itself to predict the transactor kind of a behavior, and that's where the output also would be in the similar way. But if we continue to use that model or use that model for predicting the revolver behavior, that's where the output, though we might get some output, it would be way off from the actual behavior. So the way or the segments that we use the model in is very critical. And we need to make sure that like the use case, the business use case that we are employing has a composition of the customers which is very similar to what the model development sample looks like. A couple of other callouts that we need to do is like whenever we roll out the model, it is always a good practice to have a test controller setup where we test the model output and the decisions based on the model output in the test population and then hold the control to continue the decision making process in the traditional approach way before we confirm that the model is driving incremental value and employ the model output for a broader use case. And the second one is a continuous evaluation to determine the stability of the model. As we were discussing, change is only constant. So the macro environment could change or the potential customer behaviors can change. So we need to continuously evaluate on a regular basis, preferably quarterly, to make sure that the model output continues to perform in a stable manner for the current population. If we observe any deviations over there, that is, we need to refit the model based on an updated sample to make sure that the more recent model or the more recent customer behaviors are being captured by the model and the output is being accordingly tailored to accommodate these updates. One component that we need to evaluate again is the stress part, the stress testing part. So, in a normal environment, the model output continues to be as easily applicable in our decision making process. But there are some scenarios, especially in economic downturns, which broadly impact the overall industry. We need to evaluate by placing in additional stress on the model output to see what kind of a decision it generally leads to. And the general norm within the industry has been to employ a factor typically to estimate the additional stress that we need to take on in times of like broader economic stress and evaluate if we continue to be profitable in those kind of scenarios. And this stress test typically helps determine like if the model can continue to be used or if it practically wipes out the entire population from being targeted, then that is when like we probably need a more stringent model to account for these stressful times. Now that we have seen like the entire model development journey and the application of how it can be leveraged and like how we can validate it, let's review a couple of the real world applications. And as we were saying earlier, the real world applications can come across like the entire customer lifecycle because they play a role in determining the value of a customer that the company can take on at different phases. So the first use case that we'll evaluate is related to the acquisition phase. So how can the machine learning based customer lifetime value help us determine whether we can, how we can optimize the acquisition outcome? So depending on the customer lifetime value, if we identify a segment of customers who typically tend to be high spenders or who typically tend to be like revolving on like significant amounts of the purchases that they make, then we can expect that gradually over a period of time, the money that we make from or the revenue that we can generate from the usage patterns of these customers would be typically very high. In order to attract these customers and have them open a card with us, we can potentially afford to give them higher sign-on bonuses, target them in a more aggressive fashion so that we can generate a better response rate and also have higher volume of customers coming in. So that's where like the segment targeting can benefit heavily based on the accurate customer lifetime value for the credit card. The same goes to the credit policy tuning. So we know that like we probably identify a group of customers that we can identify, that we can approve. But should we always be satisfied with just that segment of customers? Can't we actually go beyond and test for some of these borderline cases? Because for all that we know, the model predicts based on the behavior, based on what it has learned from the historical behavior. What if some of the assumptions that we make for these borderline customers are not validated, and is there a merit in actually approving these customers? So instead of approving like a whole lot of like unapprovable population, we can identify like those borderline cases and the marginal segments that we can potentially approve and try to learn their behaviors and validate the assumptions that we are making. This also becomes important in targeting some of the segments or like launching new products that we don't have any history on, and we just use some proxy to understand or to get a baseline assumption. And going into this policy tuning based on this machine learning will help us optimize for those policy gaps and the maximum identifying those maximum boundaries that we can approve the population into. Now let's evaluate another use case which is more in the customer management. So once a customer starts spending with us, we probably originate them or acquire them with say average line of say $20,000. But depending on the customer behavior, that $20,000 may not be sufficient because they continue to spend a whole lot and like they are either making like multiple payments within the month to make sure that they open up their line and continue to spend. So in a way, like we are causing a friction at that point, and eventually like if the customer gets a higher line or a better experience with any of our competitors, they would tend to migrate away from using our card at that point. To avoid those kind of scenarios, and if we are able to capture or use these machine learning models to accurately identify the true need of the customer, then we can give them a much higher line than the initial line that we gave them and continue to build on the engagement that the customer is displaying. The similar goes the other way as well. We started off a customer with say a $20,000 line, and for some reason we observe like negative behavior, signs of negative behavior from the customer in terms of them becoming riskier in servicing their loans or having transactions which probably indicate that they are turning out to be risky, like spending in risky categories or not being able to make their full payment over time or like struggling to make payments because of return payments, things like that. In that case, should we still like open ourselves to that entire $20,000 line that we gave to the customer? We do have the option of proactively reducing the line to make sure that like we do not expose the business to heavy losses and restrict our loss potential by which we would be saving on the costs. So in such a fashion, we can dynamically manage our exposure to maximize the value that we generate for the customer and also the potential business value that we get out from these customer behaviors. In addition to these, we also have like multiple retention strategies or like the fee waivers that we give out to the customers, any reward, one-time reward categories or reward accelerators that we give out based on the overall value that the customer has generated till now and could potentially generate based on their behavior. And we can give a very good experience or a rewarding experience to the customer back and make sure that like we continue to develop that engagement with them. Now that we have seen a couple of real world applications, let's see like how we can actually measure the profitability or the measure the improvement that these machine learning solutions are actually helping us generate. As we're discussing in the acquisition, if we target the right customer and we know that or we have a good accurate assessment of what kind of spend and like the balances that they can carry or that they use in the future, we would be able to accelerate the break-even period. So as I was saying, like 4 to 6 years is the average. But if we can identify the group of customers who actually spend a lot with us or who actually revolve a lot with us, we could potentially achieve that break-even in less than 4 years. So those are the kind of customers that we want to essentially target and spend more on getting those kind of customers versus still sticking to the traditional approaches and making terms on having that average break-even period of 4 to 6 years. Not just that, say the balanced risk return is where if we know for sure like what is the kind of losses that we can expect from a set of customers versus what is the potential benefit, we can make an appropriate risk reward decision to make sure that we chase higher returns with acceptable risk instead of being very conservative and going for lower returns to maintain the risk low. So using machine learning models, we can have a better and accurate assessment of what that risk reward ratio would look like for a segment of customers and optimize like our targeting strategy and be very aggressive in chasing some group of customers versus being conservative in moving out of some pockets which may seem like low risk based on the traditional data, but they could just be a ticking time bomb. In the same way, not just from the business decisions perspective, we can also use these assessments that we get using the machine learning models to have the right optimized allocation of resources, be it in terms of the human resources or like the marketing budgets that we can have or the operational budgets that we need to have to service these customers. We can focus on what would be the optimal allocation and essentially assign more resources to target high customer lifetime value customers versus having a equal approach or equal allocation to all different segments. Now that we have reviewed so much information, let me wrap up and provide four main key takeaways that we have from this discussion so far. The first one and the core concept is the customer lifetime value and how central it is to the credit card profitability. Starting from the upfront acquisition costs all the way through a dynamic customer management phase, that having an accurate assessment of the overall customer lifetime value and constantly adjusting it to the ever changing factors is a key input into how or what kind of decisions we make and what kind of treatments we give out to these customers. And this is the most important concept of optimizing the profitability so that we can continue to have a dynamic allocation of resources and make sure that we maximize the value for both the company and also the customer at the same time. The second one is how machine learning can actually help us unlock some of the predictions that the traditional univariate kind of models or analysis wouldn't help us. Behavioral modeling and using machine learning concepts can help us understand the impact of multiple variables and multiple factors on the customer behavior, and it provides us like multiple levers that we can leverage to impact the customer actions and how we can build a deeper engagement with them. And as we have seen, the applications of these machine learning solutions can span across the entire customer lifecycle, starting from the time of acquisition, going all the way through the retention phase, the customer management phase, and how they can actually play together to inform the overall profit and loss statement. One word of caution I would still like to call out is the rigorous validation. As I was saying, building a model is fine, but making sure that the business case stays true and we are taking an unbiased approach along with a rigorous validation periodically to make sure that the model is still relevant to the current times is of utmost importance. If we continue to operate on a model that doesn't make any more sense based on the customer behaviors or the changed external environment, we would be making like very wrong decisions for the business, and that is a huge cost to the business, which we would realize very late and would take a lot of impact to both the brand and also the customer experience. With that said, thanks a lot for your engagement, and I request you to please reach out to me on LinkedIn, and I would be very happy to connect with you and discuss more about the machine learning applications and the overall credit card industry in general. Have a good one. Bye.